Hi all, welcome to Anjan GCP Data Engineering. So this is one more important video on Google Cloud Data Engineering certification and concept. So in this video we will see how to select a ETL service for the given use case and the scenario. I have segregated these services based on certain parameters for our easy understanding, right? So in the first case we will see what are the different ETL services we have and which would require a coding knowledge to build pipelines. Okay, so in that category we will see a first service, that is Google Cloud Data Flow. Okay, so this is a unified stream and batch data processing service. Okay, and basically unified means so you can build a pipeline and the same pipeline can be used for batch or stream data processing with few changes. Okay, and it is fully managed, serverless and auto scalable data processes service. Okay, fully managed means we are not going to maintain the infrastructure for it and Google Cloud Platform will take care of it, and it is serverless. So it is the same concept where you are not spending any effort for maintaining your service, right? And it is auto scalable. That means based on your workload, so this can auto scale. That means it can add nodes or workers based on your workload, and once it is done it can even downscale workers. Okay, so and basically it requires a specific programming model called Apache Beam SDK. So basically it is an open source programming model, and using this programming model you can build your Apache Beam pipelines which can be run and data flow runner or data flow environment. Okay, so this is available in different programming languages like Python, Java, Go. Like Java and Python mostly are widely used programming language to build Apache Beam pipelines. Okay, and it is best suits for stream data analytics with speed. That means so when you have an unbounded source and which is continuously publishing data, and if you have to perform real-time analytics, data analytics, right, using the data, so you can use this service to process that data, and you can store that data into some data warehouse like BigQuery or else some NoSQL database like Bigtable, and you can perform real-time analytics using the data. Okay, and it supports both horizontal and vertical scalability, right? So I've already discussed this concept in our previous video. What do you mean by horizontal scalability and vertical scalability? Horizontal scalability means you can add nodes one by one, right? And based on your workload it can scale horizontally. So by default data flow supports it, it is automatically taken care by this service, and so there is a special feature called prime feature. So through this feature it's also supporting vertical scaling. That means upgrading its memory and RAM and all those configurations. Okay, and it also supports SQL transformation. We call it as a data flow SQL. So I've already uploaded a video on this particular use case. You can go to my data flow playlist and just watch this video for your better understanding. This is available through BigQuery Web UI, and I have a requirement called I need to join a BigQuery data set with a PubSub topic data, right, which is continuously coming, and I need to join both these data sets, and I'll have to perform some transformation using SQL functionality like aggregation, right? And in such use case definitely you can use data flow SQL. Okay, and also within your Python or Java pipeline, and you can perform SQL related transformation on top of your P collection. All right, and all these features are available through Dataflow SQL. Okay, I hope I'm clear. Then it's also providing pre-built templates, and there are plenty of templates available through Dataflow Web UI. All these templates segregated based on the use cases like streaming use cases and batch use cases, right? And for example, let's say if you have to move data from Google Cloud Storage to the BigQuery, right? And there is a readily available template, okay? And you can make use of that template to move data from Google Cloud Storage to the BigQuery, right? You don't have to code anything. You just make use of pre-built template. Okay, so we have already uploaded a few videos on this concept as well. You can check my playlist. Okay, And then one more feature we have called you can integrate Vertex AI with the data flow, right, in the data flow environment. Okay, so this is basically a Jupyter notebook kind of environment where you can build Apache Beam pipelines, and you can test Apache Beam pipelines. You can unit test, and you can run that on a local runner or direct runner, and you can test it, and you can even eventually launch this pipeline into data flow environment directly using this environment. And then there is other service called Cloud Data Proc. Basically, this is suitable for all your Hadoop and Spark workloads. For example, let's say there is a use case where you have to migrate your on-premise Hadoop and Hadoop cluster into Google Cloud Platform. This is the service which will be used for that use case, right? And this is also fully managed and highly scalable, okay, environment. So basically, you will create a Dataproc cluster with few clicks, and there is an option called to resize your cluster, and also there is an auto scaling facility also available. Once you create the cluster using edit options, you can always resize your cluster, and also you can go for this auto scaling facility. Okay, and it's also integrated with other Google Cloud services like BigQuery and Google Cloud Storage, and there are other services like Bigtable. Okay, what is the greatest advantage you have when you create your Hadoop Spark cluster in Google Cloud environment? Usually, when you process your Hadoop workloads to store the data, we will use HDFS. Okay, but when you use data per cluster, you can store that data into Google Cloud Storage, and you can process the data, and you can store that data back to the Google Cloud Storage. You don't have to store the data into HDFS. Okay, so what is the advantage you have? So once you are done with your workload processing or execution, you can delete this data per cluster. Okay, so that you can save the cost. Okay, if you keep your data per cluster ideal, you'll have, right, unnecessarily you'll have to pay cost for it. To avoid that, you can either switch off the cluster or delete the cluster. So when you delete that cluster, we call that concept called ephemeral cluster, right? And you can even schedule that cluster deletion once you're done with your workload execution. Okay, this is the greatest advantage you have, because you are storing the data not within the cluster, you are storing the data into Google Cloud Storage. Okay, so and then there is also other optional components you can install on Dataproc cluster, like your Vertex AI notebooks and other application like Prestation. You can go to the official documentation. There are list of optional components you can install on top of your Dataproc cluster while you create your Dataproc cluster. So we have already uploaded videos on this concept as well. Just go and watch our Dataproc playlist. Okay, there is one more feature available. Dataproc cluster can be created using custom Docker containers and images. Okay, so this is one more concept, and you can go to the documentation. So someone would like to use containers, right, to be used as part of your Dataproc cluster, you can go for this option. Okay, and one more important feature available, right, we call it as a workflow template for reusability of group of jobs. For example, let's say you have a use case and you'll have to use group of Dataproc jobs which will perform certain task, and you will group them, and you will also set the dependencies between those jobs, and you can make it as a template, workflow template, and you can schedule that template as well using some scheduler. For example, let's say if you have to reuse this template somewhere in the similar use case, you can definitely use that template. Okay, this is the greatest advantage you have with the Dataproc workflow templates. Okay, and also this is best suits for your data lake modernization. Okay, and other ETL use cases. Okay, I hope I am clear. So these are the two important services you should understand thoroughly. Okay, why? Because in the Google Cloud Data Engineering external certification, right, there are significant number of questions will be asked to test your knowledge, right, in different scenarios. Okay, especially in case of Google Cloud Data Flow, right, they will try to test your knowledge in case of streaming use cases and batch use cases. And especially when you migrate your Hadoop cluster into Google Cloud Platform, what are the additional benefit you will get in terms of cost, in terms of data processing, right, and in terms of scalability, okay, and other advantages, okay. So I would strongly recommend you to watch my playlist, uh, right, data flow and also data proc, and also go to the documentation, okay, and I hope it will really help you, okay. And then now we'll see no code data integration and data preparation services. So Google Cloud Data Fusion is one such service. This is fully managed visual point and click interface. This is not required any coding skills to build your ETL or ELT pipelines, okay. So just by dragging and dropping transformations and sources and sinks, then you can easily build your pipeline and you can deploy that pipeline, right, very fast actually, okay. And it's also providing pre-configured connectors to integrate data from external and internal sources and sinks. So source means so from where you are trying to extract the data, sink means to where you are loading the data. We have number of connectors available, for example JDBC connector, SAP HANA connectors and all those, okay. So you can make use of those connectors to integrate data from sources to the sink, and you can also perform transformations, okay. Basically it is built in with the open source service called CDAP, okay, and it's also providing pipeline portability. For example, when you build some pipeline, right, and you can export that pipeline and you can make use of that pipeline, you can import that pipeline somewhere, and it is not a platform dependent, it completely platform independent, okay. That is one more good feature we have with this Cloud Data Fusion, okay. And as I already told, it offers pre-built transformation, okay, for both batch and streaming or real-time data processing, okay. You can make use of those connectors based on your use case, okay. And one more good feature I've seen with this service, right, okay, that is called metadata and lineage at dataset level and field level, okay. So for example, let's say there is a field and you are performing transformation in multiple stages, and you would like to track that field, how it is getting transformed from one stage to the other stage. You can visually track that field transformations using this service. This is one of the great feature I've seen. Always you have to consider what is the cost associated when you are using this data fusion instance, okay. And one more thing, one important thing, when you are creating data fusion pipelines, right, visually, so in the background to execute these pipelines, it will use Dataproc cluster, right. Your pipeline automatically it will be deployed into Dataproc cluster automatically. You can even see that. So actually you are not creating Dataproc cluster. Whenever you try to deploy this pipeline, automatically Data Fusion will deploy those pipelines and execute those pipelines on Dataproc environment. So the cost is associated to maintain your Data Fusion cluster, and also since these pipelines are getting executed on the Dataproc, whatever the cost associated with the Dataproc cluster, you'll have to pay even that cost, okay. This is the combination of your instance and also Dataproc cluster usage. Just keep all these parameters in mind before you choose Data Fusion for your ETL or ELT pipeline development, okay. I hope I am clear. And then so one more important service called Cloud Data Prep, okay. This is basically this is an intelligent data service to visually explore, clean and prepare data for analysis and also machine learning use cases. So when it comes to machine learning use cases, you have to prepare data for machine learning training, okay. You can consider this data prep for your data processing and data cleaning and data quality analysis and fixing, okay. So it supports both structured and unstructured data, okay, and at scale, okay, and it will scale based on your workload and workload size, and completely serverless like other services, okay. And you don't require any code to build these pipelines, okay. So one interesting thing is, right, basically it has a recommendation system or suggestion system, I would say. Whenever you are trying to perform any transformation, right, it would basically predict and it will suggest you based on your UI input. That is the great feature I've seen with this service. Just explore this service, it is very interesting. Okay, and basically it is operated by a third party partner called Trifacta, and it is fully managed by Google Cloud Platform. Just keep this in mind. Okay, and for use cases like fast data exploration and data anomaly detection, you can use this service because it has the inbuilt capability to detect data anomalies, and it also suggests possible giants, right? So data anomalies duplicates and missing values, so it will automatically detect and it will suggest us to perform next steps to fix those. Okay, so in all such use cases you can consider cloud data prep as your ETL service. Okay, so I hope I am clear. Now we'll move on to a section called messaging and pipeline orchestration. Okay, when it comes to messaging, the first and important service comes to our mind is Google Cloud PubSub. Basically it is a no operational, secure and scalable messaging service or queue service or queue system available on the Google Cloud platform. Okay, and in order to process, okay, your real-time data for real-time data ingestion use cases, definitely you can use Google Cloud PubSub. This is a common architecture mostly which will be used to process streaming data, right? So you ingest data and you will process the data with the data flow, and you can load the data in BigQuery for your real-time analytics. In case of NoSQL use cases, you can use Bigtable for storing the data. Okay, and then it also supports ordered messaging and also any order messaging. Okay, for example, let's say in case of streaming data, right, we are not sure whether you will get your messages in order or out of order. So in order to process that type of data, you should have that capability to process both ordered or out of order messages. Okay, PubSub will support, and PubSub also supports two mechanisms to push your data. We call it as a push. For example, let's say there is a subscriber who can pull your data from your PubSub topic, right? And in such use case, we will use a mechanism called pull mechanism. Okay, this will support both these mechanisms. Okay, and also it will make sure at least it will deliver that message once to the subscriber. And one more feature we have, it can be used as a messaging middleware for asynchronous microservice integration. Okay, so that means, for example, let's say we have two different applications and they need to be integrated with some messaging service. You can use PubSub as a middleware in such use cases. So I'll give you one example. For example, let's say we have already uploaded video on this concept as well. So there is some code which has to be executed on a periodic basis. It has to be executed through Cloud Function. Okay, Cloud Function as an execute environment. Okay, and to schedule that we can use Cloud Scheduler. Okay, but PubSub can be used as a middleware between these two services. So whenever that schedule time arrives, right, Cloud Scheduler will publish something into your PubSub topic, and then PubSub topic will trigger this Cloud Function to execute your a specific code which you have written inside the Cloud Function. This is one simple example. Like that, we do have complex use cases where you can implement event driven architecture. Okay, we do have a client library support, okay, through different programming languages like Java and Python, and also it supports user defined schema, right, and you can define your own schema, especially which can be used for your PubSub topic to store the data. Okay, now we will go to the workflow orchestration service. So that is Cloud Composer. This is fully managed workflow orchestration and monitoring tool available in the Google Cloud platform. It is basically a managed service of Apache Airflow. This is an open source tool which can be used to orchestrate your ETL pipelines. Okay, and you can schedule and monitor your ETL pipeline, which can span across different clouds and also hybrid. Hybrid means on-premise and as well cloud. Okay, and it has the built-in operators which can be used to connect BigQuery, Dataflow, and Dataproc and other Google Cloud services, right? And you can easily integrate data between different Google Cloud services using these operators. Okay, and since it is built using Python, we need to have a Python skills to authorize your pipelines. Okay, that means to build your pipelines. Okay, and usually when you create a cloud composer environment, it gets created on a Google Kubernetes engine cluster, and also there is an option to create your cluster using private IPs, okay, and also shared VPCs. Okay, these are the different options you have when you create your cloud composer environment. Okay, I hope I'm clear. And so as I already told, I've segregated these services based on certain parameters for our easy understanding. This will definitely help you. Now we'll move on to a sample questions. Okay, and we'll try to answer those questions based on our knowledge. Okay, this is our first question. Okay, which of the following is a benefit of using Google Cloud Data Flow for batch processing? Okay, so just try to read this question carefully. They are asking a specific use case, that is batch processing. Okay, the first option is support for Apache Spark and Hadoop. Okay, we'll go to our document, right? And so data flow is not Hadoop and Spark service, right? This is unified stream and batch data processing. Okay, so we can simply ignore this option. Okay, now we'll go to the next option, simplified setup and management of cluster. This is true, right? Because that's where it is fully managed and auto scalable, right? And serverless. That means you don't have to spend effort to manage the background infrastructure for this service. So this is one possible answer. So before selecting this, we'll also go through the other options. Okay, the third option is highly available and automatic scaling. So automatic scaling is true. So because data flow can auto scale based on your workload. Then since it is a batch processing, I don't think so highly available is suitable parameter to consider, right? When you spin up your data flow runner, basically ask you provide your region and the zone. That means on data flow workers will be spinned up from that zone. High available means it should be available through multiple zones. Okay, so in that context, I don't think so this is the correct option. Okay, so we can ignore this. So the fourth option is real-time data processing. This is true in case of data flow, but they are specifically asking for batch processing. So in that case, you can ignore this option. So the correct option is simplified setup and management of clusters. Okay, this is the correct option. Now we'll move on to the next question. Your company has migrated a Hadoop cluster to the Google Cloud using Dataproc with the same setting as in on-premise data center. To better use the cloud environment, what needs to be improved? Okay, now we'll read option one by one. Your company should find more jobs to run to get the most out of the cluster. So I don't think so, because whatever the jobs you have on the on-premise, usually you will try to run those jobs on the cloud as well. I don't think so this is making sense, and we can ignore this option. Okay, second option, your company should migrate from Dataproc to an open source Hadoop cluster hosted on Compute Engine, because this is the only way to get all Hadoop customization needed for efficiency. This is wrong, because Dataproc itself, it is best suits for all your Hadoop and Spark workloads. This is already optimized for all the use cases. Then why do you want to install your Hadoop cluster on a Compute Engine on the cloud? So we can ignore this option. Okay, now the third option, your company should upgrade to the latest version of HDFS, change the settings in Hadoop components to optimize for the different kinds of work. I don't think so this is also a correct option, because when you move your Hadoop workloads to the Google Cloud platform, usually it is suggested or recommended by Google Cloud Platform to use Google Cloud Storage for storing your data. That means you'll have to make your data off from your Dataproc cluster. In such case, there is no question of upgrading to the latest version of HDFS, because automatically when you provision a Dataproc cluster, it is automatically taken care because you are not managing it. Google Cloud Platform will manage for us. Okay, so you can ignore this option. Okay, now we'll go to the fourth. This would be the correct answer. Your company should store persistent data off cluster, start a cluster for one kind of work, then shut it down when it is not processing the data. Because in order to save cost when you are not using this cluster, you need to shut this cluster off. When you switch off this cluster, you should not be having the process data inside your Dataproc cluster. Instead, you will have to store the data into some other storage service. Usually we prefer Google Cloud Storage. Okay, so this is the best practice. That is why this is correct option for this question. Okay, now we'll move on to the next question. This is the question: as a data engineer, you want to automate execution of multi-step data pipeline running on Google Cloud. Okay, this pipeline includes Dataproc and Dataflow jobs that have multiple dependencies on each other. The pipeline will run every day. You want to use managed service where possible. Which tool should you use? It is pretty straightforward because there are multiple jobs which have been running on Dataproc and as well Dataflow, and also there is a dependency. You want to orchestrate that workflow. Okay, in such use case, definitely it is always recommended to use Composer. Okay, this is the primary goal of Composer, right? It will be used to orchestrate your workloads. Now we'll see the options. So the first one is Cloud Composer. Definitely this is the option, or this is a service which we would use for this use case. And before selecting this, let us examine other options also. Cloud Scheduler, this is also one of the schedule service available. Okay, we can use for scheduling jobs using cron. For the given use case, I don't think so this is useful, because there are some jobs running on a Dataproc and Dataflow and there is a dependency. I don't think so we can achieve that functionality using Cloud Scheduler, so we can ignore this. Dataproc workflow templates, it is only for Dataproc jobs. Since we have Dataflow also, this is also not suitable answer. Cron is anyway we can ignore. Okay, it's the correct option for this question. Okay, now we'll move on to the next question. Your application generates a stream of data based on users interaction with a website. Okay, that means it's a streaming data. You want to transform the data and send it to machine learning model that will use it for training. Your solution requires buffering of data for a short period of time in case the data arrives out of order. Okay, which managed GCP service should you use for buffering? Okay, if you go to our PubSub service, so it has all these features, right? Buffering data, it's a messaging service. It can support both ordering and out of ordering messages. So definitely Cloud PubSub is the correct answer. So Dataflow is a it's a ETL service to process your stream and batch data. Dataproc, it's also ETL service which can be used to execute your Hadoop and Spark workloads. And Cloud Data Prep is a no code data analysis and data preparation tool. So this is also not suitable for this use case. All these are data processing and data analysis services. This is a messaging service, so definitely you can select Cloud PubSub as your correct option. Okay, now we'll move on to the next question. So you store historic data in cloud storage. You need to perform analytics on the historic data. You want to use a solution to detect invalid data entries and perform data transformation that will not require programming or knowledge of SQL. What should you do? Here couple of requirements. They don't want any programming language to code your pipelines, right? So in such use cases, definitely you should consider one of this service, because these two service doesn't require any coding knowledge. Okay, and also read this question one more time. They wanted to use a solution to detect invalid data entries and perform data transformation. Okay, so for these use cases, so we have already discussed this cloud data prep has a feature where it will automatically detect data anomalies. Okay, so for this use cases definitely you will use data prep. Okay, so we'll read these options one by one. Data flow with beam to detect errors and perform transformation. This is not correct option because it required coding knowledge. Okay, so you can ignore this option. Use cloud data prep with recepts to detect errors and perform transformation. This is the correct option. It is providing that feature to detect your errors automatically. Okay, so we'll see other options also. Data proc also requires coding knowledge. You can ignore that. Use federated tables in BigQuery. This is not at all related. Okay, so the correct option is use cloud data prep with recepts to detect errors and perform transformations. So I hope this will definitely help you. So just go through this documentation. I will provide this document along with this video description and refer this document whenever you need. Okay, so that's it for this video. We will meet in the next video.